The universe, which is thought to be an endless expanse of far-off stars and galaxies, is full of unfathomable mysteries. Yet, how might I let you know that in obscurity, past the scope of our most remarkable telescopes, lies something startling. The Space Telescope of James Webb, it is breaking down these mysteries and pushing the boundaries of what we know, a marvel of modern science and technology. However, a troubling, unanswered question remains. What transpired with these massive, ancient galaxies shortly after the Big Bang? What implications does this have for how we comprehend the world as a whole? As we investigate these findings, prepare to alter your perspective on the cosmos. The dim age of the universe, a period long stowed away from view, has been broken by the James Webb Space Telescope. It has uncovered huge, profoundly advanced objects that challenge the actual groundworks of our comprehension. These are not your typical galaxies. Rather, they are the universe breakers, superhuman beings who defy the existing physics laws. Consider worlds like our own smooth way, 500 to 700 million years after the Big Bang, it was formed. In the past, it was thought that galaxies were new, relatively small entities that accumulated mass over billions of years. However, it is right here, full-fledged and dissipated all through the universe, as though time itself has accelerated. These findings, which were published in Nature, have shook the scientific community to their core. The James Webb Space Telescope can look back to 13.5 billion years ago when the universe was young by using infrared light. It is able to capture the brightness of ancient galaxies and stars and reveal their secrets to us thanks to this ability. Yet, the revelation of these monstrous cosmic systems is only the start. What they discovered shocked scientists, who had hoped to learn more about the ancient world. These galaxies are significantly larger than 99% of the previously observed early galaxies. Most people think that galaxies started out as tiny clouds of stars and dust and grew in size and complexity. However, the observations made by James Webb suggest that the early universe was much more active and productive than we had previously thought. The initial high-resolution images data released in July 2022, these enormous galaxies were seen as bright signals. Researchers initially thought they were wrong. The worlds had all the earmarks of being excessively enormous and all around framed for the time they were found. However, further investigation revealed that these findings were accurate and wonderful. The team realized quickly that these galaxies seemed to be waiting to be discovered because they were significantly larger than was initially thought to be possible at the time they were discovered. Scientists were forced to reassess the entire history of galaxy formation as a result of this revelation, which was like a wake-up call. To gain a deeper comprehension of these galaxies, spectroscopy, which breaks down light into its wavelengths, was used by the researchers. They were able to identify the elements in these galaxies and determine their true distance using this method. The outcomes are astounding. Spectroscopy proved that these are, in fact, galaxies, but there are still questions. Behind them, could there be something else, possibly a massive black hole? The ongoing heavenly mass of the universe is 100 times greater than anticipated. The finding is still groundbreaking, even if we assume that these galaxies are only half as old as the data suggest. An international team of astronomers confirmed the existence of the oldest and farthest galaxies ever discovered by using the James Webb Space Telescope. These galaxies were discovered 400 million years after the Big Bang, when the universe was only 2% of its current age. These findings have significant repercussions. For a number of decades, scientists held the belief that galaxy formation was a slow, organic process. However, these brand-new findings cast doubt on that. Beyond our wildest expectations, the universe was able to construct structures that were both larger and more intricate. We are forced to reevaluate everything we know about the universe as a result of this realization. How quickly did these galaxies develop? What caused their rapid expansion? And if these galaxies are real, what else could be hidden away in the universe, awaiting discovery? There aren't any easy answers to these questions. However, they direct the subsequent exploration phase. A new chapter in our understanding of the universe has been opened by the James Webb Space Telescope, and it promises to be full of questions and answers. Galaxies are just one aspect of the James Webb Space Telescope's mission. It involves comprehending life's structure, Astronomers can determine a galaxy's distance from us by calculating its redshift. The Doppler effect is a phenomenon caused by the expanding universe in which objects' light shifts to longer, redder wavelengths as they move away from us. Redshift estimation is essential for knowing the ages and distances of worlds. Visual methods, which can provide an approximation using images from various filters, but precise measurements require visual inspection. This strategy separates the radiance of an item into its frequency parts, further enlightening its attributes. The James Webb Space Telescope's observations were concentrated on galaxies that have redshifts that are greater than 10^2 of these systems, first found by the Hubble Space Telescope, have redshifts of 10.38 and 11.58. However, Webb has discovered galaxies with redshifts of 13.20 and 12.63 that are even further away. These revelations are pushing the limits of what we are familiar with the early universe. Redshift 13.2 occurred just a few million years after the Big Bang, which was 13.5 billion years ago. The instruments of the James Webb Space Telescope, counting the close-to-infrared camera, NIRCam, and the close-to-infrared spectrometer, NIRSpec, had a significant impact in these disclosures. These instruments, developed in collaboration with researchers from all over the world, offer a novel perspective on the past. JADES, or the James Webb Advanced Deep Extragalactic Survey, is one of the telescope's most ambitious projects to date. JADES aims to shed light on the early universe's history over a month-long investigation. In 2015, instrument groups collaborated to propose a global survey that was comprehensive. The JADES group, consisting of more than 80 astronomers and scientists from 10 nations and focusing on the Hubble Ultra Deep Field, a small region of the sky. This locale has been concentrated on by many huge telescopes for north of 20 years, prompting the revelation of almost 100,000 far-off universes. However, James Webb has elevated this investigation to new heights. The JADES team has found a lot of information by studying the field in 9 different infrared wavelength bands. After observing for 3 days, the light from 250 weak universes was caught utilizing NIRSpec. Redshift measurements and a deeper comprehension of their luminosity and stellar mass are provided by these observations, which reveal the atmospheres and stellar properties of these galaxies. Scientists can use this data to describe how galaxies form and change over time, similar to how a person grows from a child to an adult. Understanding the start of galaxies is essential for comprehending their subsequent growth. The James Webb Space Telescope sheds new light on the processes that shaped the universe as we know it by providing new insights into these formative years. As we continue to use the James Webb Space Telescope to investigate the cosmos, a brand new era for the planet is about to begin. The telescope has responded to the absolute most significant inquiries regarding the universe. However, it likewise raises new ones. How quickly did these first galaxies emerge? How do supermassive black holes contribute to their evolution? And what other unsolved mysteries await us in space? Looking ahead, it is anticipated that the James Webb Space Telescope will operate for at least 20 years, providing numerous chances for discovery. Its advanced capabilities enable researchers to investigate the origins of black holes and the possibility of life on distant exoplanets, as well as the formation of stars and planet systems. In 2027, Webb is expected to collaborate with the Nancy Grace Roman Space Telescope on this global endeavor. These telescopes, taken together, will offer a comprehensive view of the universe and aid in deciphering the intricate web of forces that gave it its shape over billions of years. However, for now, the James Webb Space Telescope is our window into the early universe. Its discoveries are challenging long-held beliefs about the nature of reality itself and altering our understanding of the cosmos. As we keep on investigating the universe with this astounding device, the journey has only just begun. That much is certain. The launch of the James Webb Space Telescope on December 25, 2021, marks a turning point in our endeavor to comprehend the cosmos. By providing unprecedented infrared data, its primary goal is to expand and enhance the capabilities of the Hubble Space Telescope. Contrary to Hubble, Webb's infrared capabilities enable it to see through dust and atmosphere, revealing hidden structures of galaxies, nebulae, and star-forming regions. Webb operates in light and ultraviolet wavelengths. With an essential mirror 6.5 meters in width, The James Webb Space Telescope is the biggest and most impressive space telescope at any point constructed, fit for identifying faint signs from the farthest reaches of the universe. One of the greatest accomplishments of Webb is its capacity to catch light from the earliest worlds, framed only 200 or 300 million years after the huge explosion. Astronomers hope to discover the processes that led to the formation of stars, planets, and life itself by studying these ancient constellations. However, Webb is not merely looking back. Additionally, it can be used to investigate the modern universe. Its sophisticated instruments are able to examine the atmospheres of exoplanets, look for indications of habitability, and look for potential biosignatures, signs of life on other planets. As we begin a new era in our comprehension of the universe, the James Webb Space Telescope has the potential to respond to some significant inquiries within recent memory. The discovery of early galaxies opens up new possibilities for comprehending the universe and challenges our existing models. What happened to these galaxies so quickly? How did dark matter influence their growth? And could these early galaxies be the first clues to a new area of physics that goes beyond what we currently know? The James Webb Space Telescope has made the universe more clear to us. We must reevaluate everything we know about the universe as a result of its discoveries. Although we are only just beginning to comprehend the repercussions of these findings, one thing is abundantly clear: the universe is significantly more mysterious and intricate than we had ever imagined. As we anticipate the future, the James Webb Space Telescope will continue to set the standard, providing new insights into the universe. The journey has only just begun, and the discoveries that lie ahead of us look like they will be even more amazing and transformative than we could have ever imagined. For listeners, this version ought to be simpler to read and follow.